Hey everyone. Now in this video, I'm going to show you how VRRP works. So that's Virtual Router Redundancy Protocol. And basically it's a way of giving you an IP address that you can use that's virtual, that's shared by a couple of different hosts. So for redundancy, if one of them goes down, the other one will respond to that IP address. So for this demonstration, I'm going to use a couple of these controllers here, just because I've got them here doing not much else. So I've got their normal IPs set on there, but they've also got the same virtual IP address, and one of them will respond to that IP address. So what I'll do, I mean, it could be used for firewalls or controllers or anything really. I just happen to have them there. For instance, like you could have an access point that you just point to an IP address, and if one of the controllers goes down, like if, I don't know, the switch dies or someone digs through some fiber, which happened recently at a site, the other one will take over that virtual IP address and things can connect through that. But that's just one example of use. It could be any. So I'll just do a quick diagram of the setup here and then go through how it works in action. Okay, so what I've got is a controller, controller 1, with an IP address of 192.168.100.1. And I've also got controller 2 with 192.168.100.2. And I've got a router as well, and even though it's Virtual Router Redundancy Protocol, the redundancy in this case isn't this router, it's going to be for the controllers, but it's just called that. But anyway, I've got a router here that they're both connected to, so it's connected to both of them. Okay, and I've got the rest of the network out here. That's the LAN that I'll be on. Okay, so normally, if you've got a host out here and you want to ping, I don't know, that address 100.1, you would ping it, and then this router would do an ARP. So it would do an ARP everywhere, asking who has that address, and the one that has it will answer. It'll say, okay, that's me, and then the router can send traffic to it. But if that goes down, we've got a problem. So instead of that host directing its traffic to 192.168.100.1, what I've got set up on both of those controllers is this virtual address of 192.168.100.10. So this host now, instead of using just one of these controllers as its address, or switch or router or firewall or whatever the hell it's doing, we can send it to this address. Now this address is set up on both of these controllers, so that's got the config in there for that address, and so does this. Okay, but only one of the controllers will be active. One of them will be the master for VRRP. So for this VRRP address, when the router sends an ARP out for it, okay, it ARPs for that address, only the controller that has that will respond. So for instance, if this one's the master, it'll respond and say, okay, that address is here. And the switch will, let's say there's a switch in here somewhere as well. So there's also a switch that this is all connected with. Should have drawn that first. There's a switch there this is all connected to, and this switch will learn which one of those interfaces is responding to this. So at any given time, one of these hosts that's set up with VRRP will be the master, and it will send out these VRRP packets, VRRP, onto the network. And this controller over here will be in a backup state at the moment. Well, generally, there'll only be one responding to it, and it'll see these VRRP packets coming from the master. So they're multicast out. It'll see them and go, okay, those masters are over there. I don't need to do anything. Now there's priorities in that come into it, which I'll go through in a second. But basically, if this second controller here, the backup, stops seeing these messages from the master, it's going to assume something happened to it, and then it will take over. It'll start sending the VRRP stuff out, and it'll start responding to all the stuff for this virtual address here. So I'll go through with some packet captures and config now and try and explain that a bit better. Okay, now I've tried to cram as much as I could on this screen here, so I'll try and explain what's what. Over here are the two controllers, so controller 1 and controller 2. And they're just there so I can run commands and show VRRP state. And just below that here is the switch. Now it's the same switch, I've just got the port that corresponds to that controller so I can shut it and no shut it easily without thinking, and just sort of laid out clearly which one's which. So over here, I've got just pings going from my host here, pinging the first controller, which is .1, and this one here pinging .2. The one in the middle is pinging .10, which is the VRRP address. So I'll go through all this now. So on controller 1, just have VRRP 100. I've done some config here. So I've defined VRRP 100, and I'll resort to the packet capture up here. You can see some VRRP packets coming out. That virtual router ID is router 100. That means that any router, in this case controller, on the network that's part of that group for that virtual router can play this this game here. So I've only got 2, but that still shows the point. So anyway, it's pretty simple at the moment. You can have password stuff, but I've just kept it without authentication just to keep it simple. So I'll show you this one as well. Show run begin VRRP 100. And you can see a little bit of a difference. I've put a priority over here. So the priority determines which one's going to be master generally. So the default priority is 100. If you don't have anything, it'll be 100. But I want controller 1 to have a higher priority, so I just set it to 110. So all I've done really is told it the virtual IP address, which of course has to be the same on both, tell it which VLAN, and no shut. So it actually operates. So you can see up here, there's this VRRP packet coming from 100.1, which is this controller over here. And if you have a look at it, it's saying, okay, virtual router ID is 100, and no auth, and that's good. And IP address is 100.10. Now, if you look at the MAC address that it's coming from this address here, and 64 is hex for 100. So where you've got virtual router ID 100, that's 64. So that's what makes up that MAC address, and it's multicast out. Okay, so this one would have seen it as well. That one's seen it there. So if I do show VRRP 100 on each of these controllers, P100, you can see this one's state is master, this one's backup. And you can see that from the packet capture here that 1.1 is the one spitting out all the stuff, and it's responding to the pings. And for that router, I've also got it up here. If I show its MAC table here for that address, you can see that the MAC address for that destination IP is the virtual MAC address, which is being managed by this controller over here because it's the master. And on the switch, if I look for that MAC address, you can see it's in port 22, which is this one over here on the switch that it's connected to. So what I'm going to do now is I'm going to shut that port down. Oh, by the way, one more thing. As you can see here, the ads are 1 second apart. You can see this happening every second up here. So when I shut it, after 3 times this amount, it'll switch over, and this one over here, I'm just showing the VRRP over here, you'll see this is taken over as the master. And you'll see it's now coming from 100.2, same MAC address. So over here now, you'll see the pings are still going down the bottom here. It may have missed a couple, well it would have. But over here, if I show the neighbors now, it's still the same MAC address. As far as the router is concerned, it's the same destination MAC. So this router didn't have to learn anything new there. However, the switch that previously had it in port 22, if I do that again, it'll be port 20. So on port 20 is this controller, which is responding to that MAC address. Okay, so that's pretty much it. Thing is now, if I enable that port again for the first router, so what you can see is this one stayed master over here, whereas this one's still a backup. Okay, and you can still see it's coming from .2 over here. So given that I've set this a high priority, you'd think that it'd take over as master, but it won't automatically just say, well, I'm back, I'm taking over, but we can force that. So what you can do is just do a preempt on there. So I'll show you that. Show run begin VRRP 100. You can see now I've got a preempt on there. And what happened there is it went straight back to that one. It said, okay, that's a higher priority than this one. That's 110, this one's 100. And because I had the preempt on there, I said, right, look, don't bother waiting, just do it straight away. You may want that, you may not. I mean, one host that you might want priority on might be more powerful or have better bandwidth or whatever the case may be. So you might want that on for that reason. Or you might want it not to do that because this thing might be flapping up and down and you're not sure if it's good, you want to make sure things are stable before they just take over. Depends on what you want. But anyway, that's VRRP in a nutshell. Now that's all good and well, but I'm going to go a step further now and set up IPv6 VRRP on a couple of these Raspberry Pis here. So I'll just rejig the screen and go through that. Okay, I think I'm set up, but I may have forgotten something. One thing I forgot to mention before was the capture filter for IPv4 VRRP. You can just type VRRP, but for IPv6 VRRP, it doesn't work. You don't want to put VRRP as your capture filter because you'll miss it. So I'm just capture filtering for IPv6 and doing a display filter for VRRP. But anyway, here's the two Raspberry Pis, and the first thing I'm going to do is install Keep Alive D. apt-get install Keep Alive D -y. So let's do that. Okay, so they're installed now. So what I'll do, just get into the thick of things here. In etc Keep Alive D, there's a directory here. So what I've got to do is make a bit of config. So I'll start with this one, keepalived.conf, and rip into it. So firstly, I'll call it VRRP instance. I'll give it a name called 1, just whatever. Call that the master interface. Interface if0, because that's what the interface is on this thing. Virtual router ID. So I'll call it 100 like I had before. It doesn't matter as long as it's the same everywhere. And priority. I'll make it the same as I had before, so I'll have this one 110 and interval 1. So that's setting it up. So now I've got to put in the old virtual IP address, and I will use this address here. Same sort of prefix, just with 20 on the end. So I'll pop that in. Oops. That there. Okay, and that, and that. Oops, and that. So that's how it looks for that one. I'll just take a bit of a copy of that and put it in here. And don't forget my little things on the end there. Now for this one over here, I'm just going to have its priority as 100. So everything else is the same. Okay, save that and do that. So if I do service keep alive D, restart, should be right, and over here D restart, and you may have noticed down here it's responding to pings. So these VRRP messages are coming from, well, that's a link local address, so let's find out which one it is. You know it's going to be this one, but if I do that IPv6 address, that'll be its link local, so that'll be the one that's coming out of BA2C. Get this one ready over here, 6 address. You can see that it's the same as before, it's pinging away, and that's it. Now if I shut the port to this first Raspberry Pi, shut that, they should start coming from this address, E9F2. So there it is, E9F2. It's spitting the same thing out. It knows that the priorities are 100 because that's the default, and that's what I set it as anyway. I didn't have to do that, it would have been 100 by default. But you can see that that's happening there. So no shut here. And the point is, it's all there. Now what you can see, just before it changed over to that one over there, you can see the source is now coming from that other one. Just before that, if I unfilter this, you'll see in between there was a neighbor ad for 20, and it's saying it was coming from BD86. Now that's over here, so this one here, BD86 on the end of it, on the end of its MAC address, that's now saying it's over there. So if I just look at neighbor ads, just filter by that, I have filter selected, you'll see if I filter this by just that destination address, so I'll just do that for you. Applies filter and selected. Narrow it down a bit. This IP address is being advertised because we don't have ARPs, we have neighbor ads in IPv6. You can see its MAC address is here, So B1 there, if you look down here as I go down a bit, you'll see it changed to the other MAC address of the other Raspberry Pi. So that's just showing same sort of thing as version 4, but I mean, it's not going to have ARPs, it's going to have neighbor adds, and it just pumps a few out, and the switch will do the same thing as it did before, learn them, and then the pings will keep going. So that's VRRP with IPv6 on a Raspberry Pi. All right, so that's a very, very brief overview of VRRP and what it's used for. It's just a way to get a single IP address that you can point things to that actually maps to one or more devices. So if one of them goes tits up, it'll just send traffic to the other one. It'll take over as the active master one. One thing to keep in mind though is if that was a router or firewall in particular, that won't save the sessions. Like if you've already got a comms session going through, say, router 1 or firewall 1, and you've done your TCP handshake and you've got data flowing, if it dies and you suddenly go through a different one, its firewall won't have seen that initial connection, so it won't know the connection state. There are other protocols, including CARP, which CARP, which together with, I think it's called PF sync, so packet filter sync, it can exchange the states of the firewall. So theoretically, your traffic can just continue on through the backup one. But I've never set up CARP, but that's something it can do that, as far as I know, VRRP can't. Anyway, just wanted to show you that. So that'll do for now. Until next time, just take it easy.